Teaching math to students with disabilities and other students who are struggling. First, you should take a look at how you're teaching. If you take a look at how you're teaching students, you want to make sure it's effective. One way to do that is to ask yourself, are my students staying engaged in their learning experience? It doesn't matter whether you're teaching students with disabilities or students without disabilities. You still have to make sure you're doing everything you can to keep your students engaged and have a plan in place to deal with issues that may arise. You want to think about, is your teaching engaging? Is it encouraging? And is it effective? According to Renee Lestropis, the most successful part of a teacher's job often involves issues arising from students who exhibit challenging behaviors. It shouldn't come as a surprise that currently 44% of students with emotional and behavioral disorders are spending more than 80% of their day in general education classrooms. General and special education teachers must do whatever they can to promote effective academic instruction and must be able to manage and encourage appropriate behaviors. How can we make our instruction effective? Research has shown that we can do the following. We can begin a lesson with a review. We can present new material in small steps and provide opportunities for practice. We can ask many questions of all students. We can provide models. We can provide guided practice. We can check for student understanding. We can obtain a high success rate. We can scaffold difficult tasks, monitor independent practice for all material taught, and review and assess weekly and monthly. How can we increase our engagement level? Games can increase student engagement and lead to increasing the interest of all students. If we work to incorporate research-based games that go along with behavior-specific praise, students with EBD have shown an improvement in behavior and academic performance. Ray Lestropis from University of Houston does a great job explaining 4 games that we can use in our instruction to not only help students with EBD, but everyone else in our class as well. 4 of those games that she describes are Good Behavior Game, Teacher-Student Learning Game, Caught Being Good Game, and Tootling. In order to play the Good Behavior Game, you should know that it's meant for whole class or direct instruction. It rewards the entire group if each member of the group meets the goal. It utilizes positive reinforcement for the group for good behavior, and it promotes pro-social behaviors by utilizing positive peer pressure. If an EBD student has success with their behavior, they are ready to perform academically. Before you begin, you should ask the class to help you make a list of behaviors that the class would like to eliminate. Examples could include shouting out, being out of your seat without permission, negative attention seeking, and being an audience for others' misbehavior. Then you should decide on a reward, decide the criterion that needs to be met in order to get that reward, teach ways to respond to negative behaviors, draw a box on the board to record tally marks for bad behaviors. Then begin the game and provide direct instruction. If a student displays a negative behavior during the game, just make a mark on the board and continue teaching. Don't draw more attention to it. Once the class reaches the goal, give a reward. Game number 2, Teacher-Student Learning Game. The goal is to increase positive behaviors while simultaneously providing effective instruction. Prior to playing the game, you should review behavioral expectations required. Tell the class that you're going to play. Explain that students will earn a point for on-task behavior and the teacher will earn a point when they see off-task behavior. You should draw a T-chart to keep track of points both for the teacher and the students. Then you should give students a point when they demonstrate on-task behavior and reinforce the behavior with specific praise. The team with the most points wins. If the teacher wins, nothing happens. And if the students win, they get a prize that was decided upon before you began. You should be liberal with your praise and points and reward often. You want to give yourself a point if the class begins to become unruly. Third game, the Caught Being Good game. It teaches the class to self-regulate and be able to exhibit appropriate behaviors. Rather than focusing on eliminating negative behaviors, it reinforces appropriate behaviors. The goal is to maintain positive behaviors the entire time. It happens at variable intervals when you can provide this praise. If you want, for example, you could have your phone or some other alarm in your pocket that could vibrate and signal you to scan the room, looking for students who are on task. And prior to playing, you should tell the class they're going to play, and you'll be catching good behaviors for points. Discuss appropriate behaviors and model. Decide criterion that will need to be met. Designate the amount of game time. Then scan the room when you feel the vibration and give points for on-task behavior. Next, if all teams meet the criterion, they all win. You should keep track of days won by students and work toward a collective reward. To caught being good, aim produce a 20% increase in on-task behaviors and 17% decrease in disruptive behaviors for fourth graders. And there was a 7% increase in on-task behaviors and a 23% decrease in disruptive behaviors for kindergartners. It can be used to monitor behaviors while giving students time to complete independent practice or group work. It provides an opportunity to increase the amount of behavior-specific praise statements to individuals or the class. Fourth game was tootling. It promotes students recognizing their peers' positive behaviors. It's suited for use when providing instructions for cooperative learning. Positive peer reporting originally focused on students with EBD, with peers being asked to concentrate on specific students. The class learns to report class-wide positive behaviors. It promotes praising good behavior rather than tattling for negative behaviors. Prior to playing, you should discuss the definition of tattling. Then you should explain how tootling works. Next, ask for examples of when good behaviors were witnessed. Decide on an amount of toodles that will give the class a win. Hand out blank index cards to record toodles. Explain that notes should be specific by including who did it, they did what, and for whom did they do it. Read toodles at the end of class. The class is given a reward when they reach their goal. Several studies have shown that tootling has reduced negative behaviors, decreased disruptive behaviors, and increased student academic engagement both in elementary and high school settings. So in conclusion, games are interactive and motivating. They help to introduce academic and behavioral interventions in inclusive classrooms. Teachers have the opportunity to recognize and acknowledge good behavior while ignoring or redirecting negative behaviors. Games can emphasize effective behavior management and academic instruction. And special education teachers have the opportunity to collaborate with general education teachers on how and when they can be implemented. Also have the potential to be utilized in countless ways to assist students who are EBD. Next, understanding the equal sign. Students need to begin learning how to analyze the structure and properties of number sense in elementary schools. When it comes to algebraic thinking, much of student success depends on how they understand the equal sign. Research has shown a positive correlation between a student's relational understanding of the equal sign and their equation-solving performance. Many students with and without disabilities have a misinterpretation of the equal sign. It is thought that many of the misconceptions stem from students not being exposed to both standard and non-standard equation types. A study was conducted on K-5 curriculum that found that a majority of the equations presented to students were in the standard equation format. Instruction that includes both standard and non-standard equation types is known to support development of a relational thinking about equal signs. Standard format is where the equal sign is in the second to last position, immediately preceding the answer. For example, 3 plus 7 equals blank, or blank plus 3 equals 8. Non-standard formats is where the equal sign is not in the second to last position. They can include the identity property, equations with one operation that begins with the answer, and equations with more than one operation. Some examples are 8 equals 8, 11 equals blank minus 4, or 11 plus 1 plus 3 equals blank plus 6. Equations need to be constructed by the meaningful use of symbols before they can be solved. There are 2 algebraic reasoning elements that relate to an understanding at the secondary level that should be gained at the elementary level. You should teach elementary students how to meaningfully use symbols in addition to teaching them to be mindful in manipulating algebraic ideas. If a secondary school student thinks the equal sign tells them they need to do something or put the answer next, they'll be lost when they try to explain an algebraic expression like 4x equals 2x plus 1. Teachers must determine how a student understands the equal sign. If a teacher understands that about a student, They'll be able to provide targeted instruction and intervention procedures to help expose them to standard and non-standard equation formats. All teachers of mathematics must have methods to diagnose areas of weaknesses and be able to design plans to address those areas. Research supports a diagnostic interview that will allow a teacher to formatively assess a student through inquiry and action to gather evidence for intervention strategies. Diagnostic interviews have been shown to enable teachers to explore underlying issues that may have been causing gaps that could have led to increased frustration, loss of motivation and interest in mathematics, and a vicious cycle of low achievement. Knowledge gained from the interview must be used to guide the teacher's actions that will address the specific needs. Diagnostic interviews are brief and completed one-on-one. A task is presented for the student to solve, and probing questions are given that will prompt the student to tell you and show you what they are thinking. So, the inquiry phase of the diagnostic interview. You will ask probing questions to explore what the student is thinking. For example, you ask, "How did you know?" or "Why" questions. You don't want to leave yourself asking, "I wonder what the student meant by." You try to get the student to show multiple ways to solve a problem by offering a variety of materials and asking them to sketch a representation. In an effort to gather accurate data, you need to avoid providing hints, correcting, praising, or teaching students during the interview. You should record the interview or take notes that focus on what the student knows, and you need to avoid making assumptions. You will reflect on your results and decide what the student understands, what misconceptions they had, if there were any patterns, and determine if the representation showed any connections between them. After the diagnostic interview, which is the action phase, once you analyze the results from the diagnostic interview, you will work toward finding a starting place for intervention. Research has determined that it is effective to use concrete materials to support students with disabilities while they are developing abstract thinking. Providing concrete examples along with other visual representations will allow students to be able to manipulate and model concepts to help them develop a deeper understanding. Interventions will need to focus on specific misconceptions, use evidence-based and explicit strategies, provide scaffolding and feedback, incorporate both teacher and student think-alouds, and use concrete materials. Next, intervention should give the student multiple opportunities to manipulate numbers to see the equal sign as a balance instead of signaling an action. Explicit instruction is needed through concrete and semi-concrete examples of both standard and non-standard forms of equations that will allow students to develop relational thinking about the equal sign. An example of showing multiple ways to see an equation is using an actual number balance and also a pictorial representation of a number balance. You want to create an image that will show a student how they need to match the quantity on one side of the balance to the quantity on the other side of the balance to show equivalence. You should encourage students to say, "is the same as," when they read an equation to highlight the fact that an equal sign is a relational symbol and different than plus or minus signs. There needs to be a bigger emphasis in elementary schools to build the foundational concepts and skills of algebraic thinking and reasoning. If explicit instruction is provided, students with disabilities can develop a true understanding of the equal sign, a knowledge that supports algebraic reasoning and the mathematics performance throughout school. So on to ratios and proportions. Deciding if ratios are equivalent can be a difficult concept for students to understand. For example, a student may think 2 to 3 and 4 to 5 are equivalent because there is a difference of 1 between the two numbers involved in each ratio. Understanding ratios and proportion is key to many topics in mathematics and science, as well as countless real-life situations. Ratios and proportions describe the relationships between and among quantities. Students need to realize that the relationship between or among the quantities in a ratio is multiplicative in nature. A unit rate can be found even if one of the numbers in the ratio is not a factor or multiple of the other number. Equivalent ratios aren't necessarily integral multiples of another ratio. Common misconceptions. There are often examples of misconceptions with struggling students because of poor instruction provided. Students will routinely be given rules that expire, but they will remember the rules and attempt to apply them even when it isn't appropriate. For example, students are told to add a 0 to a number when multiplying by 10, but you're unable to do that for decimals that you multiply by 10. Misconception number 1 is with additive versus multiplicative comparisons. Students do not understand that 4 more than has a different meaning than 4 times. Teachers should first provide explicit instruction with modeling as a corrective measure when students have established a consistent, faulty pattern of responding, and then provide multiple opportunities for students to explain their thinking for creating equivalent ratios and use corrective feedback to repair faulty misunderstandings. Misconception number 2 deals with incorrect conceptualization of fractions. Students may say out of for 3/4 is 3 parts out of 4 parts instead of saying 3 1/4. When students say out of, the numerator and denominator both appear to be whole numbers, creating the misconception that the parts are separate quantities. Students need to be taught that a fraction like a over b should be seen as a1b to help them see that a ratio is a multiplicative comparison. For example, 3/4 represents a number 3 times larger than the quantity representing 1/4. Teachers should model correct language for talking about fractions by reading a fraction as 3 1/4 instead of saying 3 out of 4, and allow students the opportunity to practice using the same language to talk about fraction quantities. Misconception 3 involves a lack of covariational thinking. Students may look from row to row when finding patterns in tables rather than thinking about how two quantities vary together. Teachers need to ask students to explain how they determine a missing number in a table and what relationship exists between columns. Students should be taught to say, there is or are blank for every blank. Additional examples should be modeled so that students begin thinking about the relationships of the quantities. Intensive intervention for students with mathematical disabilities can be structured to promote their understanding of ratios and proportional reasoning and prevent or cut down on misconceptions. Specific lesson components can be incorporated into instruction to support students with persistent mathematics difficulties. A general structure that goes with explicit systematic instruction typically includes modeling, guiding practice, and independent practice. Explicit instruction will include problem-solving models, a range of examples, practice with feedback, and students describing their thinking process aloud. If a student has mathematical difficulties, they should receive explicit instruction regularly that will include some time ensuring they possess foundational skills and conceptual knowledge to understand their grade-level mathematics. Explicit and systematic approaches will allow tasks and questions to be developed that will encourage a student to focus on the important aspects of mathematics topics. Types of questions. Questions need to give students the opportunity to think deeply about mathematical ideas so that they can form connections across older and newer concepts. A student with persistent difficulties will benefit from a variety of questions including reversibility, flexibility, and generalization. Reversibility questions give students the answer and they come up with the question. You can give students the answers to types of questions they're currently learning and have them identify the question, or you can ask students how to use manipulatives and pictures to solve the problem. Flexibility questions ask a student to solve the problem in multiple ways or find similarities and differences between and among problems. You can ask students if they have solved a similar or different problem from the given problem. You can ask students what they know about similar problems that will help them solve the new problem. And then you can have students solve the problem in a different way using models. Types of questions and scaffolding. Generalization questions ask students to identify patterns and use those patterns to make conjectures or generalizations. You can have students identify patterns that they notice, ask students to name representations they're familiar with that work for the new problem, and have students identify a strategy they used in the past that can be used to solve that problem. You should use a variety of representations concurrently to support student learning instead of following a progression when presenting models. Presenting information concurrently will allow students to see how the symbols represent the action or relationship embodied in the physical models or diagrams. It will also help students to create mental images. Scaffolds can be used to help students access the content that may be challenging for them. Supports will allow students to work on problems that may seem difficult at first. You can provide graphic organizers or give prompts that can gradually be decreased as students improve. Small groups can allow students to hear concepts explained by their peers, and it will allow them to build confidence to share their ideas with the whole class. You can give students the opportunity to respond, and you can listen to see how they understand new concepts. Along with giving students opportunities to respond, they need to receive explicit, frequent feedback. You need to adjust your instruction through results found in progress monitoring. As students learn more, their assessment scores should increase. Misconceptions should be addressed along with determining whether a student can answer reversibility, flexibility, and generalization questions. Students should be able to explain why an answer is correct in addition to what the correct answer is. If a student routinely misses try it on your own questions, instruction should be adjusted, including explicit instruction to tackle the misconceptions and correct the mistakes. Additional scaffolds could be given to see if scores improve. If independent practice questions are not available, teachers can create questions based on current skills and concepts. If a student has persistent problems with mathematics, teachers who work with them must be aware of the possible misconceptions. Teachers will need to provide intensive interventions to help students learn the material. And if you take the time to carefully construct intervention with evidence-based strategies, it may help. You can address many of the issues that students have with ratios and proportions. Progress monitoring can allow you to see if certain strategies are working or should be adjusted to help students build through fundamental concepts of algebra. Or to build fraction sense. Research has shown that there is a strong link between a student's understanding of fractions and their success with algebra. If you begin by teaching students that fractions are magnitudes that can be represented on a number line, it helps build the foundation for learning a wide range of fraction concepts. A student needs to understand how the numerator and denominator work together to create a single magnitude. When a student is working with fractions, they must see the relationship between multiplication and division. For example, they need to understand that 4 halves is 4 groups of 1 half, 2 sets of 2 halves, and 4 divided by 2. Working with the number line will allow students to build many fraction concepts. Barriers to the development of fraction knowledge include focusing on the numerator as a counting number and ignoring the denominator and the related whole, not grasping how the numerator and denominator work together to determine the magnitude of a fraction, failing to understand that fractions are magnitudes that can be represented on a number line. If a problem asks a student to shade in 1/3 of 6 boxes, a student may only shade in one of the 6 boxes because the numerator contains a 1. If a problem asks a student to place half on a number line that goes from 0 to 2, they may place the half in the middle of the number line at 1 because it is a halfway point. This situation must show that a student understands the concept of a half but isn't able to think of it as part of an appropriate whole. In order to develop fraction magnitude understanding using the number line, you need to focus on the relationship of the numerator to the denominator and explain how that relationship determines the magnitude of the fraction. Unfortunately, a number line hasn't been used like it should to teach fractions, and most curriculum has emphasized a part-whole representation of fractions instead. You should support understanding through meaningful context. You can anchor number line understanding by putting it into a meaningful context for students to make it come alive. You can provide a real-world concept such as using a story about a race where students are set up at fractions of a mile along the racetrack. The length of the course can vary but should at least go past 1 mile to support an understanding of mixed numbers and improper fractions. Once a student is familiar with the number line in the context of a story, they can be presented with the context-free number line. You should support understanding using a limited number of denominators. Teaching a limited number of denominators helps students focus on concepts without having to consider several ways to divide something. You should just present a few familiar numbers, such as only teaching the concept of 1/2 to begin the lesson, preventing students from becoming overwhelmed with several denominators. How to create a number line race course. You can introduce students to the whole 1 mile course by having them fold a paper bar. Students can fold the paper bar to create halves where a sticker can be placed at each half to prevent students from skipping whole numbers that can be found along the course. Next, students can label where the stickers are located with the appropriate fraction. Students can see the fractions have increasing magnitudes as they move to the right or decreasing magnitudes as they move to the left. Students can also see that there are fractions greater than 1 that can continue to increase in magnitude just like whole numbers. When a student masters halves, fourths can be introduced. By gradually introducing denominators, it allows each lesson to build upon one another and provides students with a review of content learned in previous lessons and more opportunity to practice. Counting fraction magnitudes. If students orally count increasing fraction magnitudes on a number line, it will support how they think about fractions. If a student counts up for a number line that goes from 0 to 2, they can see that if the numerator is less than the denominator, the fraction is less than 1. If the numerator is equal to the denominator, the fraction is equal to 1. And if the numerator is greater than the denominator, the fraction is greater than 1. Counting fraction magnitudes. Students will begin to realize that counting by fourths takes longer than counting by halves. Eighths longer than fourths, and that pattern will continue. Students will see what a denominator does to a number. It creates more smaller parts. You can tell students to think about a family of 8 sitting down to eat a meatloaf versus a family where there are only 2 people eating. Tell students that you want each person to get an equal share and ask them what situation would give you a bigger piece of meatloaf. Make sure that they understand the bigger family requires more pieces that will be smaller in size. Ask them which situation they would rather be in. Adding and subtraction fractions using the number line can be done thinking of addition modeled as moving to the right, subtraction modeled as moving to the left. In conclusion, games are one way to practice concepts and promote fluency when it comes to fractions. When comparing fractions, you should first introduce comparing magnitudes, looking at 2 fractions with like denominators, and then gradually introduce more challenging comparisons. If you are working with students with learning disabilities and/or other difficulties in mathematics, number lines can be key to helping them build fraction sense. You should only work with a limited number of denominators. You should put it in a context that is meaningful to students that will sustain their interests. Finally, after you've instilled new strategies and things into your classroom and your instruction, you should have active progress monitoring. Monitoring the students' progress toward their goals is key to success for every student. When it comes to mathematics, it can be hard to monitor their progress in areas such as algebra. Easy CBM is an evidence-based way to monitor progress and improve student outcomes. Students are assessed on progress toward long-term goals using parallel measures of constant difficulty. Assessments can be administered quickly, and results will be displayed in a graph. Teachers can trust the scores because there is evidence to prove they are reliable and valid. PDAPM is an online system that is built to support teachers as they learn and implement materials. It has 2 hubs, with the first one being for professional development and the second for data management. The PD Hub helps teachers decide which progress monitoring tools they should use, and the Data Management Hub explains the tools that you can use to monitor progress. When you're working with progress monitoring, you should, first, acquire knowledge about progress monitoring. You should learn what progress monitoring is, and know that Easy CBM is helpful to teachers who teach students with disabilities and other students who may be at risk. Project AIMS outlines why progress monitoring is used. Next, you should select a high-quality measure related to specific content. You should select a way to measure progress that has been found as reliable and valid. PDAPM provides 3 different algebra measures: Algebra Basic Skills, Algebra Foundations, and Algebra Content Analysis. Basic Skills focuses on skills fundamental to introductory algebra. Foundations focuses on skills for understanding beginning algebra, and Analysis focuses on skills ranging from solving simple equations to solving systems of linear equations. Third, you should administer and score the measure. Each assessment is administered for 5 to 7 minutes. Students will consider each problem and move on to another problem if they don't know how to complete a problem they are given. PDAPM provides hands-on activities in which teachers score a sample of student work that they must score with a 90% accuracy in order to use the tool in their classroom. Fourth, you should gather baseline data. It allows the teacher to determine a student's current performance level, and is completed by taking the median of at least 2 scores from assessments completed at the beginning of a course. Fifth, you should set a goal. District assessment scores are used to create a benchmark for the student. You should compare data from a small number of peers to identify typical scores. It's important to note that it isn't appropriate if a student is performing significantly below their peers. You should use expected rates of growth for a particular measure, and a goal line should be made on the graph connecting a student's baseline to their goal to show the rate at which the student needs to progress to meet their long-term goal. 6, you need to deliver effective instruction and monitor student progress. Progress monitoring data alerts the teacher that their instruction isn't working for a particular student. The frequency of assessing can vary depending upon the student's needs and intensiveness of services. Students who are receiving special education services should be assessed weekly. 7th, you should review student graphs and make instructional decisions. You should look at the graphs to help you determine if instruction needs to be modified, the goals should be raised, or you just continue with the way things are. It's recommended for teachers to collect 5 to 7 data points before making an instructional decision. Teachers should use a trend line to represent the overall rate of change for a student. A teacher will know to make changes if the student is on pace to fall well short of the goal line. Then 8th, you should use student data to adjust instruction. You should analyze student work to determine the specific skills or concepts that need to be retaught or reinforced and decide how you can change your instructional practices. Why use progress monitoring in algebra? Algebra courses are continuing to include more and more secondary students with disabilities. Progress monitoring tools can allow for professional development while supporting teachers in their effort to track growth and show when to make instructional modifications. IEP meetings are a great place to be able to present progress monitoring data and graphs to the ARC. You can discuss instructional supports that are being provided for a student and decide whether alterations need to be made. So overall, no matter what, if you're working with students with or without disabilities, you need to make sure your instruction is engaging, encouraging, and effective. Games can be a great place to start when you're working to keep your students engaged and trying to stop negative behaviors. Inclusion is becoming more and more of the standard, and students with disabilities will continue to stay with the rest of their peers for a bigger part of the day. The games can be easily incorporated to help create a better learning environment for all students with disabilities. Students who are EBD will be given cues to help them change their negative behaviors, and they can receive positive reinforcement from their teachers as well as their peers. Students who have other learning disabilities will have an improved learning environment that tries to get rid of distractions that can greatly impact them. If we begin by keeping students interested in learning, the rest can fall into place. A big area of concern when it comes to students with disability deals with mathematics and the foundational skills that are needed to help any student succeed. The first thing you can do is to help students learn what the equal sign is really doing in a math problem. An equal sign is used to show that balance needs to be created instead of telling students they have something else to do or the answer comes next. Diagnostic interviews allow you to determine areas of concern and give you ideas of what concepts need to be presented in a different way for students, especially students with disabilities. Once students understand what the equal sign represents, you should move on to making sure they can grasp the concept of ratios and proportions. Misconceptions can be evident for any student. It's important to know why a student sees a problem a certain way. You need to be explicit in your instruction to correct the misconceptions. Algebra requires a great understanding of many foundational skills in math, and it can become evident very quickly who knows what is going on. Activities that center around the number line can help students with the foundational skills. Number lines provide a concrete example for students with disabilities to assist in building fraction sense. No matter what strategies you use with your students or what games you play, you need to make sure your progress monitoring is in check. Effective progress monitoring allows you to see where a student currently is, where they need to be, and decide how you will help them reach a goal. If you are monitoring progress, you can see if and when the instruction needs to be modified to help better meet the needs of students with disabilities or students with a weakness in a certain area. If you don't track progress, you're cutting yourself and your students short as a professional by not allowing yourself to self-reflect to see what is and isn't working for your students.